Hello, it's Wasim. You are watching my YouTube channel Wasim Muniri Official. Today we are diving into the important essential concept in physics called Coulomb's law. This law helps us understand how the electric charges interact each other, or how the electric charges repel or attract each other, or how the electric charges push or pull each other. As we know that there are two type of charges. One is positive charge, another is negative charge. And also by basic knowledge we also know that like charges repel each other and unlike charges attract each other. Now the question arises, how much attraction or repulsion they exert or on each other. This problem or this is solved by the Coulomb's law. It helps us to calculate the attraction, the force of attraction or repulsion between two charges. Imagine you are playing with a balloon and you rub the balloon with your dry hair, and now you will notice that when it is placed near the uh, small pieces of paper, it will attract these pieces of paper, or it also attract your hand or clothes. Well, there is a cool rule behind all of that magic, and it is called Coulomb's law. Coulomb's law is like a secret code that explains how charged things like electron and proton behaves around each other or attract or repel each other. It is a rule that tells us how much they push or pull on each other because of their charges. Coulomb's law has a fancy math formula, but don't worry, it is not as scary as it looks. Suppose there are two charges. Let us derive the formula of Coulomb's law. Suppose there are two charges Q1 and Q2, and R is the distance between these two charges. Now, according to the Coulomb's law, the force of attraction or repulsion between the two charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. The first part of this formula state that the force and the magnitude of charges is tightly proportional. Means if we increase the magnitude of two charges or the size of two charges, the force of attraction or repulsion also increase. And if we decrease the magnitude of two charges, the force of attraction or repulsion also decrease. The second part of this formula mm, explain what is the relation between force and the distance between the two charges. This here the force and the distance are inversely proportional to each other. Means if we increase the distance between two charges, the force between the two charges or decreases. Sorry, decreases. If we increase in there is an inverse relation, means if we increase the distance, the force will decrease, and if we decrease the distance between the two charges, the force will increase, and vice versa. Combining these two laws, we got F is directly proportional to the Q1 Q2 upon mu R square. Removing proportionality constant, we will get a constant K Q1 Q2 upon mu R square. Let us talk about the terms used in this formula. F is the force of attraction or repulsion. Q1, Q2 are the magnitude of two charges, and R is the distance between the two charges. Now, what is K? K is the constant of proportionality. It is a number, and its value depend upon the medium inserting between the two charges, or the medium between the two charges. K also written as 1 by 4 pi epsilon naught. The value of K is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. The value of E is equal to 8.85 into 10 to the power minus 12 coulomb square per meter square per Newton. Epsilon naught is also a constant. It is known as permittivity of the series space. This law is a fundamental law of physics. This law is very helpful in understanding the structure of atom. This law is very helpful in explaining many phenomena in nature, like lightning and how the electric current flow in the circuit, and many more phenomena can be explained with this law. Thank you very much for watching.